Welcome back to the reaction zone. In today's lesson, we're going to look at how to solve this question on the board, making use of the ideal gas equation. And the question is as follows. How many grams of oxygen gas are there in a 50-liter gas cylinder at 21 degrees Celsius when the pressure due to oxygen is 15.7 atmospheres? The value of the molar gas constant is 0.0821 liter per atmosphere per mole per Kelvin. To solve this question, we need to first of all itemize the parameters we're given in the question and then determine what we have to find. The volume is 50 liters. Temperature is 21 degrees Celsius. Now, to use temperature in a question that involves the ideal gas equation, the value or the unit of temperature must be in Kelvin. So we have to convert this to Kelvin by adding 273, and this will give us 294 Kelvin. Pressure is 15.7 atmospheres. And the molar gas constant R is 0.0821. It is also important for us to know that if pressure is in atmosphere, then the value of the molar gas constant will be 0.0821. Now, we are told to find the number of grams, that is, how many grams of oxygen. Grams is the unit for amount of substance when it is in mass. So, if we are told to find how many grams, it simply means we are told to find the mass of oxygen. So, it means we are looking for mass of oxygen. The ideal gas equation, which is P is equal to nRT over V, has the following parameters: pressure, number of moles, molar gas constant, temperature, and volume. Mass is not here. So how do we find the mass of oxygen? Now we need to recall that number of moles, which is N, is equal to mass, small letter m, over molar mass, which is capital M. So it means that in place of N here, we can replace it with M over M. So when we do so, the ideal gas equation will become P is equal to mRT over mV, where this M over M here is representing number of moles. So with this expression now, we can now find the mass of oxygen, which is small letter m. So this equation here becomes P capital N capital V is equal to mRT. And we need to make this small n here the subject of the formula. So this becomes M is going to become PMV over RT. M is equal to, the value of pressure is 15.7. The molar mass of oxygen, which is capital M, the molar mass of oxygen is simply 16 times 2, which will give us 32. So this is 32. Volume is 50 over molar gas constant is 0.0821, and the temperature in Kelvin is 294. So when you solve for this, the mass of oxygen, which is small letter m, is going to give us 1.04. times 10 raised to the power 3 grams. I hope this calculation involving the use of the ideal gas equation is clear. Thank you for watching and see you some other time.